So next up, we have Chethna Kabeerdoss, another Texas A&M student who is a 3D technical artist specializing in effects.
Hello. Good morning, everybody. My name is Chethna Kabeerdoss. I am a graduate student at the Texas A&M University. I'm doing my master's in visualization. I work with Dr. Anne McNamara and a fellow student, Conrad Egan, and we're researching the merits of mobile eye tracking in augmented reality. Now, my talk will briefly explain our idea and our implementation and the preliminary results that we've got from our experiments. The idea, basically, is to integrate information about where the user is looking when, and deciding what information to present. The problem is amplified when it's in a mobile AR platform, and the reduction in the real estate imposes a challenge. Now, our paper describes the research that we've developed for principal algorithms for optimized integration of the real and virtual world elements in a mobile AR platform. Now, augmented elements can quickly overpopulate an augmented display, leading to clutter and confusion. Now, attempts have been made to regulate the way the elements are delivered to an AR environment and to make sure they're visible and understood. But none of these previous attempts take into factor where the user is looking. Our solution takes us where the user is looking and place the information only in the area where the user's gaze is. Now, augmented elements such as text and annotations can contribute to visual clutter. And sometimes they can overlap and not be that legible. So there are methods like the greedy algorithm, the clutter-based algorithm, and the screen subdivision methods, but no existing research uses the gaze information of the users. Now, using the gaze information of the users, this will make the placement of the labels more effective and ensure that the placement does not obscure the important information in the screen. We've considered 5 different strategies for AR information placement, and those would be: the first is the naive method, where we don't take any eye tracking data into consideration. The second one is called the direct proportional method, where we use the relationship between the label anchor point and the tracked position of the screen, the eye tracked position of the screen. The third method is called the spatial hysteresis method, where we use an entry radius and an exit radius, and once the user's gaze is around the entry radius, the labels would pop up. And we use the fourth method is called temporal hysteresis, which uses some time-based way for the labels to stay on screen till the user reads them. And the fifth method is the spatial and temporal hysteresis combined. Now, we conducted user studies for these methods, and the techniques and we've used 2 platforms. One was the LCD platform, and one was the iPad. And the dependent variables that we took into consideration were the accuracy and the time taken for them to respond. The spatial hysteresis method, where we have an entry radius and the exit radius, seem to perform as good as the naive method, where no eye tracking is taken into consideration. Now, the main motivation for using this gaze strategy is such as spatial hysteresis would be to minimize the visual disruption. and that is introduced by placing all the labels at a given time. So we know that spatial hysteresis, because of our experiments, perform as good or even a little bit better than the one with no eye tracking data. So the results that we've obtained show us that by using the method, like using eye tracking, we can actually eliminate visual clutter. And you can see what the information that image actually presents, and then look towards it for more information that you want. So we have much more work to do in this, and we are considering taking this approach and our solution to a configuration consisting of the Google Tango and coupled with eye tracking, and see where our results take us. We expect to see more improvements on the performance of our strategic placement based on eye tracking. If you have any questions, please feel free. Thank you.
Thank you, Chethna.
Good presentation, Chethna.
Thank you.
What mobile eye tracking platforms are you using?
We're using Vuforia to design the scanning part, but we're actually using this platform called FaceTime. Yeah, so that's what we're using. Thanks.
Hi, Chethna.
Hi.
I'm Oz from Intel. I was just wondering, this is a very good idea.
Thank you.
I was just wondering, how do you have maybe a video or something that works to show? I think this would clarify a lot of the questions or ideas that you have.
Okay. So you want to see a video of our working? I can show you the experiment after this presentation, but right now what we're doing is we're conducting user studies just to figure out the best strategy, and I can show you the setup if you want. Yeah.
That's about all the time we have for questions. Thank you again, Chethna.
Yeah.